Question 6 involves investigating standing waves and where to use data in the table to calculate the speed of sound in the pipe. Well, initially we have the pipe something like this, and the standing wave would have a node at the bottom and an antinode at the top, something like this. So I've got my bad drawing, and that is L1, and that is 3/4 of a wavelength. With the shorter pipe, L2, we then just have a node at the bottom and an antinode at the top, and this is L2, and this is just a 1/4 wavelength. So L2 minus L1 is going to be lambda over 2. This comes out at 0.506 meters minus 0.170 meters, which is 0.336 meters. Therefore lambda is 0.672 meters, twice this value. Then we can use V equals F lambda. Frequency we're told is 500 Hertz times 0.672 gives a speed of 336 meters per second. In part B, the experiment is repeated but with the frequency at 5000 Hertz, whereas to suggest and explain whether these results are likely to give more or less accurate values for the speed of sound. Well, the higher frequency gives a smaller wavelength, so the uncertainty in measuring the length will be a bigger percentage of the length, meaning a lower accuracy. In C, the pipe is now removed from the water and laid horizontally on a bench. The frequency sent down the pipe is adjusted until a standing wave is set up, and we have point P, a 1/4 of a wavelength from the far end Q. We're to explain how and under what conditions a stationary sound wave is formed in the pipe, describing and comparing the motion of the molecules at P and Q. Well, the wave from the speakers reflected off the open end of the tube with the same frequency and wavelength, and with a similar amplitude. The two waves will interfere constructively at antinodes, forming a large amplitude oscillation, and they'll interfere destructively at the nodes, forming a zero amplitude oscillation. Both open ends will be antinodes, so point P will be a node with zero motion, whereas point Q is an antinode, and the air particles will have maximum displacement to the left and to the right.